Hello, my name is Marcelo Taparelli and this is my Capstone project. So for my project I decided to create a scale model version of a Wagon Tippler, which is a machine used to unload open carts. So what this machine does is it pulls the cart into the machine, locks it in place and turns it upside down for unloading. Now for controlling it, I actually have a joystick here that will control this linear actuator and also a button that will control the arm and the electromagnet. So if I pull the joystick to the side, I can actually inch the carrier closer to the cart. Once the carrier is close enough to the cart, I can press the button to lower the arm and activate the electromagnet. Then I just inch forward until the cart is locked in place. Once the cart is locked, I can pull it back into the machine. Once I'm happy with the position, I can just press the joystick again to unlock the cart. I'll move the carrier away just to make room for the machine to rotate. Once that is done, I can press the button to lock the cart onto the machine. The cart is now locked and the angle is set to 0 for rotation, and an LED is on just to make sure that it's informing the user that the cart is ready to be flipped. Then I press the button to flip the cart. So the cart flipped 140 degrees and rotated back to its original position. Now I have an option of giving a sound warning to warn anyone around it that the cart is ready to be taken out of the machine and a new cart is ready to be loaded. Now, if there's another cart waiting to be loaded, I can actually take this cart and also push the other cart out of the way. Okay, so now we're going to focus on the controller side of things. I already have my carrier close to my cart just to show the joystick can move it back and forth. And once I click the button on the joystick, I activate the electromagnet, turning the LED on and also attaching it to the cart. Once the cart is positioned in place, I press it again to unlock it. Now, when I press the first button, it will lock the cart in place, it will tear the scale and also show me the initial angle. So when I press the second button, it will unload the cart. Now the cart is unloaded. It turns a different LED on to show me that I'm in my last stage, showing the weight unloaded, that's 93 grams, and also allowing me to signal the machinist by pressing this button. So I can signal, showing them that they can bring the next cart in for unloading. And once pressing the first button, I go back into first stage and lock the cart. Alright, and lastly, we're going to focus on the PCB side of things. Controlling everything, I have an Arduino Nano microcontroller here, and it's controlling the stepper motor by using the stepper motor module, which is set up by these dip switches here. So one of them controls the enable disable pin and the other one controls the micro stepping functions. Then I have a micro OLED display here showing the weight and the angle of the cart once the stages are set. On this area of the PCB, I have this chip which is an H bridge with all the necessary circuitry to rotate the cart upside down and back. And here is my load cell module, which is analog to digital converter that will take the information that is on the load cell underneath this tray here and convert it to a signal that the Arduino can actually read. On the top here I have the power modules. So this is a linear regulator just for the electromagnet because it draws a lot of current, and this is the second linear regulator used for powering all the other modules. So here I have my gyroscope module mounted on the back of the Tippler with the servo motor that activates the locking mechanism. Okay, so this was my Capstone project. I hope you liked it, and if you have any questions, I'll be happy to answer them. Thank you.